Alright, as we have said in the previous video, now there is no any division between the process variable, that is what you are trying to control, and the set point, that's our target. For in the case of level, we assume our target is around, okay, let me reopen. Okay, let me reopen the controller for you. Now this is our set point. Okay, the set point is our target. Okay, while the process variable is the variable we are trying to control. For this reactor, we are trying to control the level of the fluid inside this reactor, and we set the set point to be 0.914. Well, that one is actually integrated, is incorporated from our steady state solution. Okay, and look at it, the process variable presently is the same thing as the set point, and in order for us to maintain the differences between this set point and the process variable, that is our target and what the plant is really giving out as the output. Okay, this is the plant, which is the reactor. It's giving out the signal that is being sending out is that, okay, the process variable, which is the level, is going to send the signal into this controller, and when it sends signal into this controller, the controller will compare it with the set point. If there is no any difference, then it's going to open this loop, this flow. It's going to open it with this amount of flow rates. Okay, I hope we get that. All right, this is what is going to be maintaining as a flow when there is no changes in the difference between the set point and the process variable. Okay, and another thing I want us to know is that, let's go to configure, and we already have the unit. Now this thing is where I was saying the other time, the difference between direct acting, the controller action, and reverse acting. Now look at it. When we have direct acting, I said it the other time that the input, when the input to this controller increases, for direct acting, the output of the controller will also increases. How? If the level, that is the process variable that you are trying to control in this reactor, if it increases, that is probably going above the set point. If it is going above this set point, for instance, if this is the process variable and this is the set point, look at the legend. The process variable and set point, they are on the same line, so we can't really see the difference between them. Let's say, for instance, this blue line, the process variable, go above the set point like this, then it has really worked above our set point. In order for us to maintain that, this controller will open the valve here, because we are using flow driven. That's why there is no valve here. So it's going to open this here. It's going to open this and increase the flow rate in order to release more liquid out of this reactor. Okay, I hope you understand that. So that is what we call direct acting. Okay, and in the case of the reverse acting, if we check the configuration for this temperature, okay, look at it. The set point, that is where we are going, where we want the temperature of this reactor, we want the temperature to be 70 degrees C, nothing more than that, nothing less. Okay, the moment, and this controller is reverse action, it should be for temperature, because if the temperature of this system, of this reactor, if it is more than 70, there is need for us to remove more heat. That's just as the process variable, that is the temperature that we are trying to control, as it increases, there is need for us to remove more heat. There is need for us to remove more heat in this system, and that is why it is in reverse. That is, if this increases, if the temperature inside this place increases, then there is need for us to decrease the energy that is being consumed. Okay, the input to this controller, this temperature controller, if it is high, okay, that is temperature is higher, then the output is that we should reduce the energy that this one is generating. Then that one, if that one is by increasing the flow rate of the code stream. Okay, so with that, I hope we are able to get the difference between reverse acting and direct acting. Okay, now the next thing we want to do now is that I can close this configure tab, close this, and now in order for me to go back to where it is before, I will click on to rerun, to reinitialize. So I click on this, so everything has really gone. Now in order for me to this, we are using automatic. In automatic, you can change the set points, okay, and in manual you are allowed to change the manipulated variable. Okay, for the level controller, the manipulated variable is the output, the flow rate. Okay, all right, now to want to study the effects, how is the present configuration parameter, the tuning parameter, how is it able to behave? The default configuration parameter, how is it, what is the behavior, what is the response to set point change? And that's what we call servo. Okay, now if I want to make a step increase of 75 degrees, for instance here, then we will see. Now let's run. If I run, let's say at 1.5 minutes, I want to make a set point change of 75 degrees. Okay, let me pause here. I can pause. Okay, at 2 hours, I want to make a set point change to the temperature. So I will try and see the response of the system. So let me put 75 to our set point. We are no more using 71, the reactor to update at 75 degrees. Okay, by that, when I press enter, it will have changed. Then let me continue the run. Okay, can you see the temperature has increased? It has increased. So by that, we can conclude that, and you can see that there is no change. Okay, if you really study it very well, you can see that change in temperature does not affect the level of the control or of the reactor. Okay, so the temperature will be, change temperature will be a disturbance to the level controller. Okay, while change in temperature for this one is a set point change. So with that, there is no change. So there is very good response, and it really gets to the set point. You can say the control structure is very good, and it quickly gets to the set point value immediately with a very quick response. Okay, so I can really reinitialize this again to get back to my steady state value. Then I want to rerun and change the level of the controller, and let me see what will happen to the temperature when there is change in the level of the controller. So I will rerun again, and when it gets to 1.5 hours, I will change to, I will make the set point to be 1.5. So at 2, you can say 1.5. Okay, can you see change in the level of the controller, of the level of the system affects the temperature of the system. Okay, but there is no there is no high definition in the system. Okay, so I hope you've really gotten to learn some things this present tutorial. In the next video, we are going to study more on the change and control strategy that can be used. Okay, and by that we've answered question the B part of the question. Okay, and here we can answer the B part, and the C part and D. We have already answered the C part anyway. That's the last one we did. It was not B. Now we can answer the C part and D part again using our own control structure by using this. And I say for practicality, okay, we want the minimum for the process variable, that is the level. We want it to be 0.625. okay, that is 25% subtracted from the steady state value and 25% added. That's for practical. It is always good whenever you are doing the control, if you want to set the minimum and maximum, because we said it the other time that you cannot allow. Can you see the default for the level? The default for the level range is that the level can be 0, and it is not good. You cannot allow your reactor to have zero flow inside, the zero liquid inside. So we want to set this, so I can close this. I can click initialize value to change this back, to bring back our steady state value inside. Okay, can you see? Oh, sorry, initialize value. I can click this, so it go back. This is this one that we use. So that one will take it back to our steady state value. So I can close this and close every one of it. Then I can reconfigure it. So I reconfigure this level controller by going back, by double clicking on it, go to configure. Then we are asked to use, let's go to range. We are asked to use the minimum range of 0.6855. 0.6855. So to enter the value, you press enter. Okay, it will accept it. Then for this, we have 25% added to the steady state value. Okay, and we know the steady state value is 0.9 something. So when we take 25% of the steady state value, when we take 25% of the steady state value and we add it to the steady state value, we are going to get 1.1425. Then I will put it here, 1.1425. Okay, then I press enter and it has accepted it. And for the output, that is the flow here, and this is the steady state. Okay, this is the one that will run for the steady state value. If you look at the previous, this is the steady state value, initial one. It is not this. This one is when it was from. So when we take 25% of this, we subtract it from this, then it will be the value that will be here. And by that, I've really calculated it. I have this to be 15812.7. 15812.7. Okay, and the maximum will be 2635.4.5. 4.5. 35.4.5. Okay, with that, press enter, then it will be accepted here. Then I can really close this. Then we have our system miracle. I double click back on this. Can you see? Okay, then the next thing is to change that of the temperature. I can go to configure the same way. Then I I want it to be 25% subtracted. That's from 70 degrees. If you take 25% of it, then we subtract it from 70, then we have 52.50. 52.50 as our range. Minimum 52.50, and here it will be around 80 something, 87.50, 87.50. Okay, then for the manipulated output, because this value we have to, if you want to make use of this value, this unit, then you have to take 25% of this and remove it from the steady state. I mean, this is steady state value. Then you remove it from the steady state to get this, and you take 25% of the steady state, which is this, and add it to this. Okay, then with that, for my own, when I did it at the first time, this is a kicker. Okay, what can I do to, because you can't change the unit here, but actually let me see what I can do. Okay, this one will be minus 1.44653. That's the minimum. This is the minimum energy to remove. That negative means it is being removed. Okay, and this one will be minus 0.6868. Press enter. Then we have this, and the value has been taken. Okay, then I can, okay, how I pick this, it's from the steady state value. Then you can see from steady state value, this is the heat duty of the reactor. Under the reactor results is this. If you take 25% of this, okay, you subtract it from this, you should get for the minimum, which is this. I mean, you add it to this, which is this, because it's negative, and you take 25% of that, this is minus 0.8 something, then you get, and you add it to that, you are going to get this minimum. So if I want to run it and check the, okay, if I want to do the study now based on the configuration that we picked, then I can say I want to see the plots, and let me run. Let's see the results, and we've seen this. So there is no really any change. Okay, let me go back to dynamics and reinitialize to bring back our steady state value. Okay, then let me run initialization mode. Okay, and I like to, okay, from the configure. Now we used to configure the tuning parameters. We used to use it for level. There is no need of big gain and integral time. Actually, if we are using P only controller, then there is only need for gain. And from our problem statement, we said we are using P only controller. So we are using P only controller. Okay, so, and the control variable is this, and manipulated variable, and we are using direct. And that goes to, for according to Taros Lieben, if you are controlling level, the normal gain to use is 2. Normal is 2, and there is no integral time. And in order for us to remove integral time, we can enter a very high amount like 60,000, and press enter. Then can you see this is okay now? Then we can close it and run. Okay, let me see if the conversion parameter and run it again. Let's go to dynamics and run again. Okay, then it's bringing it. Then let me pause here. And let me have a set point change. Okay, let me say 1.1, and mind you, the change that you are going to make must be within the range that you choose. So I can press OK. Then let me run and continue. Let me continue the run. Can you see? So by you not seeing the process variable, there is no difference between the process variable. It's because the control structure and the parameters that were used were okay. Alright, and let me see the effect of this changing on the temperature controller. If I double click on it, okay, then let me see the plots. Can you see the effect of the liquid level control that we control? Is a disturbance to this controller, and look at the process variable. It later reached the set point anyway. Can you see there is difference at this point? There is difference between, look at the point that will make change. This is the point that will make change. At 1 hour, we make change to the level, and it affects the temperature. So far so good. I think you've had some idea on how to do controller tuning and how to simulate, how to study the dynamic behavior of the system in Aspen. Thank you very much once again. My name is Joel and I'm from ismartsynergy. God bless.